In this video, I'll show you how to create color images from the data taken in the LCO project. We're going to use a piece of software called Cyril. It's a cross-platform tool and it's free. There's a link to it. So download and install the latest version. We'll be using image files that have already been calibrated, so we don't need to do that process. The previous video showed how to download the files and then compress them. So by now you should already have your images in 3 separate filters, one for each filter. Run Cyril. This free software is still under development, so the version you have may look slightly different to this, but it should be similar. If you don't want to use Cyril, then feel free to use whatever software you're familiar with. There's many of them around. The first thing you need to do is to set the working directory, so click on the Home button and choose the directory where your 3 folders are for the filters. Cyril works with something called sequences, so go to the conversion tab first of all, and from the V folder drag the files into the right hand window. Set the sequence name to V, choose fits images and symbolic link, although that option may not work on your system, and then click on the convert button and let the process complete. When we get to the other filters, using this button here will clear any files from the list, and that speeds things up a little. Now we need to register all the stars in each image so that we can stack them. Click on the registration tab, choose global star alignment, and then click Go Register and let that process complete. Now we're going to stack all the files into one image for the V filter. So click on the Stacking tab. For method, choose Average Stacking with Rejection, and for rejection choose Windsorized Sigma Clipping and click on Start Stacking. To see what the V image looks like, at the bottom of the screen you can click on the Auto Stretch or Histogram option. And this is only for display purposes. It doesn't actually affect the data itself, but it does allow you to see what the image might look like. Now we've done it for the V filter. Go through the same process for the RP and B filter images, and then you should end up with one stacked image for each of the 3 colors, V, RP and B, and that's green, red and blue. So now we have those 3 color images. We need to create a color image out of those channels. So for the image processing menu, choose RGB compositing. So choose the appropriate file for the RGB images. Those are the 3 stacked images that we created. But because these 3 separate images aren't aligned yet, we need to align them. So on the red tab at the top left, drag a box around the central part of the image. For alignment method, choose Image Pattern Alignment, Planetary / Deep Sky, and then click on Align to align the 3 color channels. If you now click on the RGB tab at the top, you'll get your first view of what your color image might look like. The colors are going to be slightly odd because these aren't filters that we would normally use for color imaging, so you will need to adjust the colors. And now it's over to you. So this is your chance to get creative. Look into how Cyril works, watch some of the tutorials, or just try it. Press a few buttons, see what happens. You can play around with lots of features such as color balance, background neutralization, stretching, noise reduction and cropping, and all the other functions that you'll find under the image processing menu. So see what you can create out of this data. I would suggest you use more images than I did. The more you use, you'll get a deeper image and less noise, and come up with the best looking image that you can. and hopefully you'll learn a little bit about image processing at the same time. But feel free to use whatever tools you're familiar with. Even if you use Cyril, you could use something like Photoshop or Lightroom or GIMP to finalize the image. But overall, just have fun. So that's the end of this video. In future videos, we'll talk about working with the data exported from the Hoyes database in other apps, and also the science. What do the light curves that we look at actually mean?